I think I also read that you spent some time working on flight control software. Is that right?
Yeah, I got after spending all the like 5 or 6 years working on servers and hard drives. I was the manager for the hard drive team, and had done a lot in that space. I wanted to try something different, and Google being Google, it has a lot of different areas that are going on, and it just happened that around that time was just before the whole shift to being Alphabet and having the other bets, but X had existed for a while, and there were some of these more grandiose, like very different ideas, not the typical Google development things. And one of those was building a satellite internet project. So a LEO constellation of satellites that provided internet access. And if this sounds a lot like Starlink, that's because it is. This is actually a predecessor project, and through a series of unfortunate events, the team forked, and part of them went to create Starlink. So common lineage there. But yeah, I was working on flight control systems and a lot of the high-level architecture for how the system would work. When you're designing a satellite, you kind of have the part of the bus. They call the satellite the bus. The part of the bus that's responsible for keeping the satellite where it needs to be and doing all of the flight related things. And then you have the payload, and they're supposed to be entirely separate systems. Like they should have no interaction really. And so I was mostly focused on flying the bus. But a lot of that was just figuring out what did it need to do, like what were the sequencing that needs to happen, what sort of orbital maneuvers would we need to do. I learned way more about orbital mechanics than I ever had intended to ever learn. But I was only with that project for, maybe a year or so before that project got turned down. And that's around the time that Starlink got started up. And but one of the pieces that we had built or started to build out of this was, like, even though I was mostly focused on the flight control side, officially, I was working with a lot of folks that I knew from the server teams and the networking teams on, there's an interesting data routing problem. Like, how do you actually build a network that goes through multiple satellites? Because you not only have the classic networking problems like in Wi-Fi of what's my quality of my link, you now have a problem of everybody's moving. And so the potential set of links that you could form is constantly changing.
Right.
So I was working with them through that problem because it was just kind of fascinating. And we ended up building that system. And we ended up calling it the first spatio-temporal software-defined network. And it literally is. It's a cluster system that just kind of evaluates where everything is in space and evaluates all the potential RF links based upon the radios and pointing capabilities that each of them have, and comes back with solution sets so you can predict in the future where it's going to go. And that ended up following through a couple different follow-on systems of repurposing it, because we built the system to track anything. We didn't care how it was moving. So it was like, oh, we're not on satellites anymore? Well, guess what? It works on aircraft. Oh, you're not on aircraft anymore? Well, the Loon folks with their balloons, they could use that too. You want to do between balloons and aircraft? Sure, why not? So that project actually continued on and eventually got spun out, and some friends of mine still run that as the company. I can't remember the name. But yeah, so that's actually a product that they're trying to sell now on the market.
Yeah. Was the so obviously, Starlink has gone on to be successful by a lot of measures presently. What was kind of some of the blockers at that point in time? Were there any technical blockers, or was it mostly organizational in terms of that project's fate within Google?
I mean, yeah, there were a lot of challenges. Not only like from a technological standpoint, there was a lot of how do you actually build LEO to ground radio comms that tolerate basically how do you build the ground station, or like the user access terminals, not the gateways. But there were a lot of challenges with just the technology for building the antennas and stuff to hit a price point. It would be trivial if I could have you spend $5,000 to buy a steerable antenna, but that's not practical for that type of system. So the idea of getting to that, panel that's actually a phased array of all sorts of antenna elements was a lot of technical development that was going on. And Starlink has definitely moved in that direction and shown to be successful in that area. There was a lot of other aspects in terms of the software backend of, not only the data routing, but the flight planning. We had a lot of discussions around how do you actually keep in touch with all of the other organizations that you need to about potential collisions in space. Like, there are processes established for this, but they were never designed for this scale of the number of satellites in space. And so they don't have the ability to do that conjunction analysis that fast. So there were problems associated with that, like, lots of different things. But from a technical standpoint, a lot of it was, how do you just build the radios? How do you build the power systems? How long is the satellite even going to last before you have to intentionally deorbit it? And a lot of those turn directly back into business problems. If I have to replace a satellite every month, that's expensive.
Right.
Yeah.
So you mentioned also kind of like collaborating with the server and networking folks during that time. I'm not very familiar with the architecture of satellites, and especially internet satellites, if you will. Is it essentially like a flying server? It kind of sounds like I couldn't help but draw analogies between what you were talking about with the flight control system and the BMC that we were just talking about doing similar operational tasks for the server.
And it's not a bad parallel. The main difference is that, a flight computer has to be radiation tolerant. It has to not fail effectively. Right. Otherwise, your satellite's completely useless. And that's the worst case, right? Like, the absolute worst case for a satellite is you lose control of it and it's just there and you can't intentionally deorbit it. Like, if the payload fails, I can intentionally deorbit it and get it out of space. Out of space, right? I can get it to burn up in the atmosphere. And that's a much better result than having it just be there as inoperable. So the flight computers and the everything related to flying the bus tended to be spec'd for much higher reliability and a much longer lifespan, so that you were pretty confident that you'd be able to fly the thing even if you lost the ability to use the payload to actually run the data comms.
I see. And I can't help but think about as well. And this, you mentioned the episode with Nathaniel earlier, and we talked about their CT scanners. And naturally, what came to mind to me was, how are you updating these systems? Partly because I work for an IoT company during the day, so we're always thinking about OTA updates and that sort of thing. What was the software update process like for these satellites?
We didn't actually get that far in terms of the development. Okay. I mean, it was like, try to make the system work first and figure out what all components you were going to have and then figure it out. But it was definitely a very key thing on mind of a firmware update that kills the machine is not okay, right? Like, you have to be safe no matter what happens. And so there were a lot of thoughts towards, how do I actually get the system to come up in a mode where I can use one of the radios to basically be a serial port to the console port and be able to upload things over X modem if I have to, kind of stuff.